So you discuss something about PN junction theory. Related to that, you discuss some examples. See, for now, in the GATE exam, so the questions of three types are there. One is the objective model, other one is nothing but numerical data type questions. And recently for GATE 2021, he introduced that MSQs, means multiple select questions. In the case of multiple select questions, what you say means the answer should be more than one you can call. See, for now, first of that option I go, that is objective condition. So in the case of objective condition, for the given question, he given the options. Among that, you may going to be pick out the correct answer, right? So first option I can able to go objective model. See this one now. So for a P plus N junction, NA means acceptor density, on P side, that he given is 9 into 10 power 16 per centimeter cube. ND stands for donor density, you can call. That given is 1 into 10 power 16 per centimeter cube. So density of doping on N side, density of doping on P side. So the total depletion layer width is 3 micrometer, you can call. And calculate the width of the depletion region on P side. He asking what is the width of the depletion region on P side. So he given the option is 3 micrometer, 0.3 micrometer, 2.7 micrometer. None of these things he call. So this is the objective model, right? So now let us see this one now. What are the thing for that? So first you check up this. NA given is 9 into 10 power 16 per centimeter cube. First you write down the data. What are the thing he given? And ND equal to 1 into 10 power 16 per centimeter cube we can call. So acceptor density on P side, donor density on N side, right? And the total width of the barrier W is given 3 micrometer. He asking that what is the width of the barrier on P side. WP is asking. Just now you discussed that the width of the barrier on P side, you discussed that formula, right? So WP equal to what means total width into opposite density, that is I told ND divided by ND plus NA. ND plus NA you can call. So now I substitute now. W is what means 3. ND is nothing but what means 10 power 16. 1 into 10 power 16 it is. Divided by ND plus NA you can call. ND is 1 into 10 power 16. NA is 9 into 10 power 16. So taking 10 power 16 common, that is 1 plus 9 into 10 power 16. So anyhow it is in micrometer. Resultant should be in micrometer. So 10 power 16, 10 power 16 cancelled out. So 3 by 10, it become 0.3 micrometer. So for one of the thing you remember, for objective questions, negative marking is considered. If it is a 1 mark, so if it is wrong, means 1/3 cancellation is there. If it is a 2 marks question, means a 2/3 is there. So for objective type questions, you mustn't should have what means a negative marking, So see this one now, the answer for this one is nothing but B. Okay. So correct answer, no negative marking you can call. If it is wrong, you can have, suppose it is a 2 marks question, means a 2/3 loss is there. If it is 1 mark, means 1/3 loss is there. So next question I can able to go. In an ideal PN junction, eta equal to 1. Eta means ideality factor. T equal to 300 degree Kelvin, that is room temperature you can call. Calculate the magnitude of reverse bias voltage required to reach 75%, of its reverse saturation current rounded off to 2 decimal places is dash millivolt. It look like what means fill in the blanks type. So here in the GATE exam it to be called as a numerical data type question. Why to be called as a numerical data type question means through your computer keypad you are unable to enter the units. Only have a ability to enter what means the numerical thing. That is the answer. So what are the decimal places he asked? After that decimal places you write down. So what are the answer you want? In that question itself he give the units. So you want the answer here in millivolts. So what is the advantage of this type of questions means? So what are the student who know these things only can able to attempt. So no guess. And even the answer is wrong, for that no negative marking. So this type of questions introduced from 2014 onwards. So virtually it can carry around 40 to 50 marks in the GATE exam, right? So these are called numerical data type questions you can call. So now I can able to check out this another type of question in the GATE, that is a numerical data type. So for a PN junction, eta ideality factor is given, that is 1 you can call. So eta means ideality factor, that is 1 is room temperature T equal to what means 300 degree Kelvin you can call, right? So you're asking that what is the magnitude of the reverse bias voltage required to reach that 75% of its reverse saturation current you can call. So magnitude of reverse bias voltage you can call at what means the corresponding current reach what means 75% of its reverse saturation current you can call I equal to minus 0.75 I naught. Why I use negative means because it is a reverse bias. Already you know that in the case of reverse bias, the current to be taken as a negative you can call. 75% means minus 0.75 I return. So you know that in the reverse bias, you see this one. Already you learned that in reverse bias, the current I or IR what you can call I equal to minus I naught. Okay, current I equal to what that means minus I naught you can call. He asking that what is the magnitude of the reverse bias voltage required to reach the corresponding current to reach the value of 75% you can call. So now I can able to go for that. So your standard equation of current in PN diode from Shockley, you know. So this is the Shockley equation. We know that I equal to I naught into exponential of V by eta Vt minus 1. This is the standard equation of current for a diode, you know. So where I naught is the minority current, you know, V is the applied bias voltage, you know, eta is the ideality factor, Vt stands for thermal voltage. So this is the room temperature T equal to 300 degree Kelvin, you know. There Vt stands for how much means 26 millivolt. Originally Vt equal to T by 11,600 I told, that equal to how much means 26 millivolt, you know. Vt equal to how much means 26 millivolt you can call, right? Now I can able to substitute the things. What you can call means at I equal to minus 0.75 I naught, what is the magnitude of the reverse bias voltage you can call? Now I can able to go for that. At I equal to minus 0.75 I naught, what you are getting means, so minus 0.75 I naught equal to I naught into exponential of V by eta Vt minus 1 you can call. So I naught out. So take 1 this side, 1 minus 0.75, that become 0.25 call, right, equal to exponential of V by eta Vt. Now I need that V value. V equal to, remove exponential become ln, you know, eta Vt ln of 0.25 volt. Okay, V equal to eta Vt ln of 0.25 volt you can call. So V equal to eta Vt ln of 0.25 volt you can call. Okay. So now I can able to examine this. V equal to eta is how much there? 1 into Vt is 26 millivolt there, right? Ln of 0.25 volt you can get. So if I minimize this, what you can get means minus 36.04 millivolt you may get. Minus 36.04 millivolt is there, but he asking that magnitude of that, then modulus of V equal to 36.04 millivolt. So you already asked the thing in question is in millivolts he asking. So the answer you may apply is nothing but 36.04. He asked that up to 2 decimal places he can call. So see this one now. So he asking that answer is nothing but adjusted to 2 decimal places he can call. In millivolts he asking. So that becomes how much means 36.04. This is the answer. So for this type of question, even your answer is wrong, for that no negative marking. So this is the advantage to the students who prepare well for the GATE exam. So no random guess for the answers you can call. So this is one more type you can call, numerical data type questions. Next question I go, which of the following is associated with the PN junction you can call? Which of the following is associated with the PN junction? So this is one more type of question you can call, that is called as a MSQ question, multiple select question. When do you call the answer is multiple select question means in the given options, the answer should be more than one, then it is called as a multiple select question. So that is now going to be introducing in GATE 2021 now, so that you can able to examine. Mostly in this multiple select questions, you may have only theory part questions. Check out this. So which of the following is associated with the PN junction you can call? A, junction capacitance. B, charge storage capacitance. C, channel length modulation. D, depletion capacitance. See, so now for a PN junction, because of the barrier effect, junction capacitance is exist, that you already learned somewhat. And this junction capacitance in forward bias condition have charge storage property, because in forward bias the majority carriers can move across the junction of a barrier. Based on that, there is a charge storage phenomenon that to be considered in forward bias of the PN junction. By that, what are the capacitance of the PN junction in forward bias to be called as a charge storage capacitance? Okay, this is also correct. Next one, channel length modulation you can call. Channel length modulation is not related to the diode body. It comes in a MOSFET body, enhancement MOSFET. So channel length modulation is not related to the PN junction, so it's a wrong one. Next one you can able to go, depletion capacitance. It is also the capacitance considered by a PN junction under the depletion, means removal of carriers from the junction you can call. So when the carriers are removed from the junction means that to be happen in the reverse bias you can call. So it is also with the junction capacitance, that is nothing but a depletion capacitance you can call, related to the PN junction under reverse bias. So depletion capacitance you can call. So it is related to the PN junction under the depletion, means removal of the carriers from the junction. Where it is happen means reverse bias. So it is also related to PN junction. It is also the correct. So the right options for this one is A, B, and D. So the answer should be more than one here. That to be called as a multiple select question you can call. That to be what you can call multiple select question. So these are three variants in the case of GATE exam. One variant is what means objective type. Another one is numerical data type. Other one is what means this type of MSQs that can be going to be introducing now recent into GATE 2021. Okay. Check out the next one of that. So the voltage across silicon diode at room temperature is 0.71 volt. The voltage across silicon diode at room temperature is 0.71 volt when a current of 2.5 milliamperes flows through it. If the voltage across the diode is increased to 0.8 volt, calculate the new current in the diode. Confirm now? So voltage across the silicon diode at room temperature is how much? 0.71 volt. When a forward current of 2.5 milliampere is there. If the voltage across the diode is increased to 0.8 volt, what is the new current in the diode he asking? So first I can able to go for the data what he given. See, so now this is a silicon diode you can call. For silicon diode, ideality factor is 2, right? Room temperature you can call, that is at room temperature of 300 degree Kelvin, Vt equal to how much means 26 millivolt you can call. Okay. So given that the current, suppose I say that I equal to 2.5 milliamps, right? At a forward voltage of 0.71 volt. Okay. You're asking that what is the current when the forward bias voltage become 0.8 volt you can call, right? See, so now this is the current I1 I can call at a forward voltage of some V1. This is the thing I can call I2 at some forward voltage is V2. So now I need that corresponding current at another voltage of 0.8 volt now. So now it is the condition of forward bias. You know that what is the approximate equation of current in forward bias? In forward bias, I equal to I naught into exponential of V by eta Vt ampere. So this is the equation of current, approximate current equation in forward bias, you know. Now I can able to indicate these things. So I1 with respect to V1, I2 with respect to V2 now I can call. Here temperature is a constant, means no change in I0, no change in Vt you can call. So I0 and Vt are temperature dependent persons. So temperature not be changing means no change in I0, no change in Vt. And ideality factor also say because material is not be changing. So it should be also say only I and V are interrelated there. So based on that, now if I write that one now, I1 equal to I0 into exponential of V1 by eta Vt, and I2 equal to I0 into exponential of V by eta Vt I call. Right. Now what will I do means I do that division now. I2 by I1 equal to I0 cancelled out. So division of exponential nothing but this is V2 there. Division of exponential is nothing but what means subtraction of those terms. That is V2 minus V1 by eta Vt. So now I need the value of I2, substituting that one now to get that corresponding thing now. Now I can able to check out that. So now I can able to apply that one now. I2 equal to I1 into exponential of V2 minus V1 by eta Vt ampere. Okay. So what is I1 given? I1 equal to how much means 2.5 milliampere is there. Exponential of V2 is 0.8, you know. V1 is 0.71, right? Eta is for silicon it is a 2, you know. Vt is at room temperature 26 millivolt. So 26 into 10 power minus 3. So it is in milliamps you can call. Okay, it should be what you can call means milliamps you can call. So it should be what means milliampere. So if I calculate that one now, that corresponding current become as around 14.1 milliampere. So this is the current at a forward voltage of 0.8 volt.